Alright guys, welcome back to my YouTube channel. In our last video, we talked about or we introduced differentiation. In this video, we are going to continue from where we stopped and solve some other examples on that first part, then proceed to other functions that can be differentiated. So before I continue, please do not forget to like, share, and subscribe to my YouTube channel. So we talked about the first case of differentiation. We said, let me draw a table because we are going to need this table for differentiation. So the table is this. We have a function, and this is the differentiation of that function. So the first one was y is equals to this. We said when you differentiate this power will come down to meet this guy. Then when this power comes down, we'll have a times n, then x is to the power n. So this is number one. Number two. So before we continue, let's solve some questions on this. So let's say we have f of x, find f prime of x at x equals 5f prime of 2. Let me put it that way, find f prime of 2. Find f prime of 2. What does that mean? It means differentiate at the point where x is equals to 2. If f of x is 2x squared minus 3x plus 4. So for us to find f prime of 2, we need to know f prime of x first. What is f prime of x? It means differentiate this function once. If you see f prime prime, it means differentiate twice. So differentiating this guy once, according to this rule, this guy comes down here. We have 2 times 2. 2 times 2. That'll give me 4. Then I subtract 1 from this power. That becomes 2 minus 1. That's x. Then when I differentiate this guy, the power here is 1. 1 times 3, we have 3. Subtract 1. 1 minus 1 is 0. So x is to the power 0 is 1. Then in our last video, we said whenever you differentiate a constant, you get 0. So that's like plus 0. So what are we looking for? F prime of 2. It means x is equal to 2. So this is it. For anywhere I see x, I simply replace it with 2. So that becomes 8 minus 3. 8 minus 3, that's going to give us 5. So this is the first question we have been able to tackle. Question 2. Let's differentiate if y is equals to 4x cubed minus 1 over 3x squared. Find dy dx. Find dy dx. Let me open a new place. Y is equals to 14x cubed minus 1 over 3x squared. Let me be sure. Yeah, x squared. We're asked to find dy dx. Simple. To find dy dx, or before I start finding dy dx, let me rearrange everything. So this guy has to go up so that it will look like the standard. So if the guy goes up, this 1 over 3 is still there, but this x squared goes up. And when it goes up, the power becomes a negative power. If it comes down back, the power becomes positive. If it goes up, negative, and so on and so forth. So basically, we want to find dy over dx. How do we find dy over dx? Based on our last video, this power will come down to multiply this guy. 14 times 3, that's 42, if I'm not mistaken. Yes, 42. Then we subtract 1 from this power. That becomes x squared. Then minus 2 will come down to multiply this guy. We have minus 3 times minus 2. Then don't forget that we are going to subtract 1 from the power. So our dy over dx is equals to 42x squared plus 2 over 3 x is to the power minus 3. So because I said we don't usually want a negative power, we only made this power negative by bringing it up because we want to solve. But we are done solving, we do not want a negative power. So what we do, we drop it down. So our dy over dx is 42x squared. If I bring this guy down, we have plus 2 over 3. So this guy is coming down to meet 3. The power becomes positive. And this is our dy over dx. So let's do one more calculation, then we'll proceed to other cases of differentiation. One more calculation and we'll proceed to other cases. So let's say we have question 3. If y is equals to 3 square root of x raised to power 5 plus 4 all over x square plus 13x cube, find dy over dx. This is easy, don't be scared. So before we find dy dx, let's first of all arrange this. Now they didn't say cube root, they said 3 times square root of this. So this 3 is just like a constant. Square root means over 2, cube root means over 3, fourth root means over 4. So this becomes x raised to power 5, square root means over 2. So this is the actual power of x. Then we are going to take this guy up so that the power becomes negative. Then we have this. So this is how it's supposed to be. Then now we can now differentiate. So to find dy dx, this power comes down. So we have 3 times 5 over 2. Then we subtract 1 from the power. Do not forget that. Then for this guy, the power also comes down, which is minus 2, comes down. Then we also subtract 1 from it. Then lastly, this guy, the power comes down. We have 13 times 3. Then we subtract 1 from it. Don't always forget. I'm sorry, I didn't subtract 1 from it here. I'm sorry about that. I didn't subtract 1 from it. Dy over dx. So this is 3 times 5, that's 15 over 2. Then if I do this subtraction, I will have 5 minus 2 all over 2. Yeah, these two come up to meet this guy. Then we have minus 8x raised to power minus 2 minus 1, that will give you minus 3, plus 13 times 3, that gives me 39. Then 3 minus 1, that gives me 2. So 5 minus 2 over 2, that's 3 over 2. So whenever the power is 3 over 2, what does over 2 mean? It means square root. So our dy over dx becomes 15 over 2. Then this guy is square root of what? This power, which is 3, x cubed. Then when this guy comes down, the power becomes positive. Then plus 39x squared. This becomes our answer. This becomes our answer. So let's proceed to other cases of differential equation. So basically, if you differentiate exponential x, you will get exponential x back. You are actually supposed to cram this table. You are supposed to cram this table. It's supposed to be a part of you. If you differentiate exponential x, you get exponential x back. Exponential e is just a number, 2.8 something. Just a number, just like pi. When you see pi, you think of 3.142, which is 2 over 7. So e is just a number. Then if you differentiate natural log of x, you will get 1 over x. Please take note of this. If you differentiate natural log of x, you will get 1 over x. You will get 1 over x. Then also, if you differentiate sine x, you will get cos x. If you differentiate cos x, you will get minus sine x. If you differentiate tan x, you will get sec square x. Yeah. So there are other ones, but I won't do that in this video. In subsequent videos, we'll add to this. So pause this video and try to memorize these things. I'll count 5 seconds. Pause it. Try to memorize. So let's do a quick test. Close your notes. Do not spy. Just close your eyes. Do not watch this video. Just listen to my voice. First question, if you differentiate exponential x, what will be your answer? 1, 2, 3, 4, 5. If you got exponential x back, that's the correct answer. You are very correct. Next one, if you differentiate ln x, natural log of x, what would you get? Correct. The answer is 1 over x. If you didn't get 1 over x, you are wrong. Next one, if you differentiate tan x, what will you get? If you got sec square x, then you are correct. If you differentiate sine x, what will you get? If you got cos x, then you are correct. That will be all for this video. Please do not forget to like, share, and subscribe to my YouTube channel. In subsequent videos, we are going to be solving more and more questions on differentiation, including all these cases that are here, and we'll add to this table. You can also go online and check for differentiation table. You will see many other functions there. In our subsequent video, we'll solve more questions. Thanks for watching.